mask off. All right, so there's one more property of exponent rule that we're going to cover today. I split it up because last time was hard enough. I didn't want to try and get through it all, okay? So we're going to deal with negative exponents today, okay? So a negative exponent is like a shortcut way to write division, all right? So you don't have to write this part down. I just want you to watch so you can kind of understand where this trick is coming from, okay? So don't worry about writing this down, okay? Just watch. So if I have 2 to the 4th, then that, if I were to multiply all that out, I'd get 16. 2 cubed is 8. 2 squared is 4. 2 to the 1st is 2. And 2 to the 0, last time we talked about, right, is 1. Now, if I were going to get from 16 to 8, I'd divide that number by 2, right? And I'd divide that number by 2 to get from 8 to 4. Divide 4 by 2 to get to 2. Divide that number by 2. Well, this pattern, because that's what math is built on, actually keeps going into negative numbers. So notice how the pattern here is I'm minusing 1 in my exponent every time, right? Which would mean the next one would be 2 to the negative 1st. Well, if I'm going to continue the pattern over here, 1 divided by 2 is 1/2. 2 to the negative 2 ends up being 1 over 2 squared. Negative exponents. Now, this is just me showing you where it comes from. So if that was tricky, then pretend I didn't do it, okay? So here's the idea, is that when I have a negative exponent, it's a shortcut way of writing a fractional base without having to write the fraction. So today we're going to practice working with negative exponents. So if I wanted to rewrite this as a positive exponent, what I would do is first have to imagine the invisible fraction. So there's like an invisible 1 there. Then, if I want to change it to be a positive exponent, what I'm going to do is I'm going to take this and I'm going to move it to the other side of the fraction, and that changes the exponent to be a positive number. So negative exponents are fractions in hiding. Now, whenever I do this first one, sometimes people are like, oh, so you just like flip the fraction. That's not actually what we're doing. So let me give you another one that's similar to this so you can see. So let's say I gave you instead this one, write this one down. Okay, so one where the fraction wasn't invisible. So t to the negative 7th over 3. Don't worry about this. This is just my note to change this example next year. So the negative exponent right here, right? If I move that down, the 3 isn't going to move up because the 3's exponent is just a regular positive 1. So what would happen is I just move the negative exponent down. Okay, so we're going to do a bunch more of these today. This is half our lesson today, so it's okay if it doesn't click perfectly yet. Just stick with it, okay? So on this first one, first of all, those parentheses are dumb. Why are they dumb? Why don't they belong there? I don't need them. Why? There's nothing outside of them, right? So let's just rewrite it again without the parentheses because there's nothing outside of them, so they're not needed. So now I can't have negative exponents in my final answer. So to rearrange negative exponents, they rearrange on the fraction. So I'm going to take just the part that has the negative exponent and multiply it by what's on the top. So 1 times r to the positive 1, but the 5 stayed down because it didn't have a negative exponent. Its exponent was positive 1. Okay, let's do one more together and then we'll write the property out, okay? So let's say I gave you 3 over 2x to the negative 2. So the reason I put the 3 and the 2 there on the outside is just so you see that because there's no parentheses hooking those together, then they're not attached, so they stay the same. The only thing that moves is going to be the negative exponent part, and it's going to move to the other side of the fraction line to change from a positive exponent to a negative exponent. Okay?
Why'd you multiply for the 1 over 5r and not for the 3 over 2x?
So I did multiply. So with multiplication, sometimes I write the dot, sometimes I don't, but they both mean multiplication. So if it makes more sense to write the timesing dot, then you can, but then my answer is still going to be the 3x squared over 2. So with multiplication, if they're right next to each other, you can kind of assume they're being multiplied. Does that make sense? Okay, good. What else? Okay, negative exponents are fractions in hiding. Okay? To make a negative exponent positive, move it to the other side of the fraction. So just take a second and get that definition, and then we're going to do a couple examples. Good? Okay, so let's look at example A. So I like to do my other rules first and deal with the negatives last. You don't have to do it that order. I just think it's easier, okay? So if I was going to deal with my rules from last class first, these are two things being multiplied with the same base, right? So I would add their exponents together. So I'd have 3k to the negative 3 plus 2. So same base, so I added the exponents together. So 3k to the negative 1. Now on last night's homework, it was totally fine for you to have the negative exponents just because I hadn't gone through it yet, but technically that's one of our things we shouldn't have if it's all the way simplified. So our simplifying rules are this: only one of every number, one of every letter. Those are the two ones from last class. And then our third one and final one is no negative exponents, okay? Is that all right? Okay, so now that I added those together, I got negative 1. I look, oh, okay, the 3's fine to stay where it is because it has a positive 1 exponent, but the k can't stay there. So I'm going to take it and move it down. So 3 over k to the first.
Would 3 over k work?
Sure. Okay, now on B, okay, and again, you don't have to do all these steps if you're starting to get the hang of it and you're getting them right and stuff, but on B, you may want to put in, like we did last class, our multiplication dots just to realize that these things aren't attached to each other. And then maybe rearrange them so that the numbers are together and then the letters are together. Now 3 and 2, I'm not going to add those because they're not exponents, right? So literally just multiply those numbers out like you would normally do. So I'd get 6. And then these being multiplied, I'm going to add those exponents together. So that would give me 6n to the negative 2. And then I got to move my n squared down, but the 6 can stay. So 6 over n squared. Good? Okay, I want you to try, C's a little different, we're gonna do that together, but I want you to go on to the next page and I want you to try F, and I'm gonna walk around and answer questions before I move on to the next